Hello, in this video, I will go over special right triangles, specifically 44, 45, 45, 90, and the 30, 60, 90 triangle. So after at the end of this section, or after the end of this video, what you could do is find the missing side lengths of those special triangles. So, oh yeah, so just like what I said, in this video lecture, I will go over two types of special right triangles, the 45, 45, 90, the 30, 60, 90 triangle. And then at the end of the lecture, you should be familiar finding those missing side lengths of those two special triangles. Okay. So first, let's talk about the 40, 45, 45, 90 triangle. So on the image on the right, that is a 45, 45 triangle. 45, 45, 90 triangle is also known as an isosceles triangles because within an isosceles triangle, the two sides are the same. So this side is congruent with this side. And the reason why is because this angles are the same. So if you have two congruent angles, you have two congruent side lengths. Yeah, you have two 45 angles and two legs are the same. If you have one of the leg, so if you know one of the leg, you can easily find the hypotenuse. All you got to do is multiply the hypotenuse by radical 2. So let's explain. Let me explain that more in depth. So here you have a 45. There a 45, 45. Let's say you had one known leg, 5, right? Let's say this leg right here is 5. This leg here also has to be 5, right? And then how would you find the hypotenuse? Well, they say that the rule is the leg times radical 2. So our leg is 5 radical 2. Okay. Okay, what happens if they didn't give you a leg? Let's say they give you a hypotenuse. So let's say this hypotenuse is 10 radical 2. So how would you find the leg? The leg is just the number in front of the radical. So this leg here would be 10, and then this leg here would be 10. That's it. I hope that doesn't sound too confusing, but we will go over examples. So yeah, this is your typical 45, 45, 90 triangle. Now let's go over the 30, 60, 90. So on the image on the right, please disregard the left one because we just went over the 45. It is, yeah, disregard this one. It's the image on the left. So a 30, 60, 90 triangle means that none of the angles or the side lengths are the same. So you kind of have to be kind of careful on this one. Just because you have one leg doesn't mean the other leg is the same length, right? If you have one of the leg length, you can easily find the other leg in the hypotenuse, right? So let's actually go over this triangle. So you have a 30 degrees right here, and then you have a 60 angle degree here. So the angle, the second largest angle would be 60, and then the smallest angle would be 30. So the second largest angle will give you a side length of x radical 3, and then the smallest angle will give you a side length of x, right? And then the hypotenuse, or the one with the 90-degree side, will give you a hypotenuse of 2x. So what does that mean? So let's say you had a smaller leg, or this 30-degree angle, had a leg length of 5. Could you find the rest? Yes, you can, right? What would this leg be? So according to the rule, it says it's x times radical 3. So in our case, our x is 5, so it'd be 5 radical 3. And then you can find the hypotenuse is just 2 times x, so it's 2 times the smallest leg, which is 5. which is 10, right? So you could easily find anything if you have at least one side length. You'll be fine. So yeah, in this case, we have to remember that the second largest angle, or the 60, has a length of x radical 3, and then the smaller angle has length of x. And then the hypotenuse is 2 times x. Okay. Let's do some examples. So on example 1 says find the value of x and y in each triangle. So here we have example 1, and we got to find y. In our case, it would be the hypotenuse, right? And we got to find x. So first, let's determine which type of triangle this is. This is a 30, 60, 90, right? Okay. So according to your notes, 30, the smallest angle, has a length of x, right? So this is your x, which is 8. And 60, or the second largest angle of a 30, 60, 90 triangle, has a length of x radical 3. So could we find x? Yes. You just put it in this formula. So we say that our x is 8, or this one of the smallest leg is 8. So it's going to be x radical 3. So this x, or this leg, or the leg of the 60 degrees, is 8 radical 3. Now, how do you find y? Well, y is considered the hypotenuse, and because it goes with the 90. So according to the 30, 60, 90, to find the hypotenuse, it's 2 times x, or 2 times the smallest leg. So in our case, our smallest leg is 8. So it's 2 times 8, which is 16. So your y value is 16. Okay. Oh, maybe here. I don't know if this will help, but if you go back to the rules, there's 30, 60, 90. So this is 2x. 30 has a length of x, and 60 has a length of x radical 3. Okay. So our x is 8. And then this would be 8 radical 3. And then this is 2 times 8, which is 16. Okay. Yeah, let's move on to the next example. Example 2, find the value of x and y in each triangle. Okay, so on example 2, oh, I forgot to write this, but this has an angle 60. So yeah, so that means that this angle has to be 30, because remember, the sum of the triangle should add up to 180, so you have no choice for this angle to be 30. So this is a 30, 60, 90 triangle. So how do you find x and y? So, okay, so let's look at 14. 14 goes with the angle 30, right? And according to the rule, the smallest angle is your smallest leg, or your x value. So your 14 is, your x value is 14. Now 60 is one of the second largest angle, or technically the second largest leg, or the biggest leg. And according to that rule, 60 has a length of x radical 3. So that means y is going to be 14 radical 3. Okay. And then 90, this hypotenuse is 2 times x. So it's 2 times the smallest length of the smallest leg. So that would be 2 times 14, which is 28. Okay, so x is 28, or the hypotenuse, and y, or the largest leg, is 14 radical 3. Okay, let's move on. Wait, go ahead and absorb all that. I know it's a lot of information. Okay, let's move on to example 3. So example 3 says find the value of x and y in each triangle. So here we have an angle that's 30, a right triangle, and then we have a 12, and we have to find x, which is the hypotenuse, and we have to find y. So this is technically a 30, 60, 90, right? This is definitely 30, 60, 90 triangle. So according to a 30, 60, 90, angle 30, or the smallest leg, is x. So x is 12. And then the largest leg, so the angle 60 goes with length y, side length y. So y is the largest leg, and according to the rule, it says it's x times radical 3. So it's just going to be 12 radical 3. Okay. So your y value is 12 radical 3. Now, what about how do you find x, which is technically the hypotenuse? So according to the 30, 60, 90, to find the hypotenuse, it's 2 times x. So in our case, it's 2 times 12, which is 24. Okay, so x is 24, and then y is 12 radical 3. Okay, go ahead and take time to absorb, and let's move on. Okay, this is example 4. So, oops. Example 4 says find the value of x and y in each triangle. So let's see. So that we have an angle 60, we have an unknown leg, which we have to find. And then y is also an another leg, right? So this time they give us the hypotenuse of 60. So this is definitely a 30, 60, 30, 60, 90, 30, 60, 90 triangle, right? So we only have one side length, which is the hypotenuse. And according to the hypotenuse of a 30, 60 triangle, it's 2 times x. So what you could do is you can say that 6 equals to 2x, right? And then let's go ahead and solve for x. So you would have to divide this by 2. So x equals 3. Okay. Now that doesn't mean x is 3. Then x is 3. So what that means is actually it is x equals 3, because angle 30 goes with the leg x, which is technically the smallest leg, and the smallest leg is just labeled x, and which we said is 3. So x does equal to 3. Now let's find y, or the largest leg. According to the rule, to find y, or the largest leg, you do x radical 3. So that would just be 3 radical 3. Okay, so that's it. You found the two legs, and then the hypotenuse was already given. Let's stop here. Let's do the other example, the last examples on another video.